Good evening, ladies and gentlemen. Let's make this quick. Uh, we went over a little bit with composite functions. I'll just do a broad recap to show you what happens when we get to inverse functions. Remember, a composite function is a function inside of a function, and we usually notate that with f of x and g of x, and written f of g of x. Now, remember, we did these four in class, but just to really go over it one more time so that we are clear. If g of x equals the square root of x, then really we're trying to find f of the square root of x. And f of the square root of x would just be 3 times the square root of x minus 5, because wherever we see an x, we just put square root of x. G of f of x is the other way around, so this is going to be g of 3x minus 5, and then we just take the square root of that. So the square root of that will just be the square root of 3x minus 5. That's what g tells us to do. So if we're looking for f of g of 4, g of 4 is equal to 2, so we're looking for f of 2, and f of 2 would just equal 6 minus 5, which is 1. And f of 4 would be 12 minus 5, which is 7. So we are really doing g of 7, which is the square root of 7. All right, so that's what composite functions are. When we did these, not really worried about this one and this one. We did those in class. So doing this one down here, we do f of 2x minus 4. And since we did f of 2x minus 4, then that's really 2x minus 4 plus 4 over 2. And the 4's cancel out. We're left with 2x over 2. We just got x. And then here was pretty much the same thing. We're doing g of x plus 4 over 2, which is just 2 times x plus 4 over 2 minus 4. These cancel out. You're left with x plus 4 minus 4. Those cancel, and once again you get x. So since we get x, that's when we came to the part where we figured out that those are the same thing. So since those are the same thing, we got that since they gave us the same thing, they both gave us x. We got that these two are inverse functions. So that means that this is an inverse function of this and vice versa. Now, this is where we got to this part. An inverse function, f and g are inverse functions if you get this: f of g of x equals x for all x in the domain g, and g of f of x also equals x for all the domain of f. All that means is that if the points in f go a, b, then they go ba in the other function if in fact they're inverse functions. Earlier we tried to graph two functions, the functions that we had here. If we graph both of those functions, they look like this. Now notice on this line, on these two functions, so say this one right here, I'll say this one right here is x plus 4 over 2. So let's say this is f of x, and this is g of x, which is 2x minus 4. So say we have those two functions. Hold on. That's better. Inverse functions basically is one line, and it's rotated across this line right here. Well, this line right here. The equation of this line right here is always y equals x. So notice this. So notice one function, the function f of x, just flips over that line to become g of x. And that's what it means to be inverse functions. So also notice where the points are. You have here, you have negative 2, 1. So if this is your A and that's your B, over here, it's just flipped to be B, A. Negative 2, 1, and 1, negative 2. Same thing with these 2 points. Negative 3, 1 half, negative 3. So you can see why they're inverse functions. If we, yeah, I just told you that part. If we keep on going, this is how we check if in fact a function has an inverse function. So there are some functions that don't have inverse functions, and you'll see the difference. It has an inverse function only if you draw a horizontal line across, and it only, every horizontal line just intersects once. So say, for example, this function right here. I believe this is f of x equals x cubed. If we go across, if we just do horizontal, that's not a horizontal line, but if we just do horizontal lines, and it only hits, each horizontal line only hits the graph once, then it has an inverse. So this one has an inverse. If we do another one, this one right here, if we do horizontal lines across, and it only hits the graph once, this has an inverse. So it has an inverse. This one right here, if we do horizontal lines going across, notice that each one of these horizontal lines hit twice. So this horizontal line hits here and hits the graph here. Hits the graph here, hits the graph here. So this does not have an inverse. So that's what it means to show if in fact a function has an inverse. Now when we do problems like that, we'll have to be able to find the function, we'll find out if the function has an inverse. So this is what we do. First thing is, you graph the function to determine whether it has an inverse. Next thing, if it does have an inverse, then you have to graph the inverse by just reflecting across the line. So let me show you what that's like. If I take this graph and I'm doing f of x equals x cubed minus 1, let me just get a chart of some points that I can use. So let's get a chart, some x's and y's, or f of x's. All right, I want to see what it does across a good amount of points so I know what's going on. Let's do negative 2, negative 1, 0, 1, 2. Just see what it's doing. All right, if I plug negative 2 into this function, that means that f of negative 2, which is equal to negative 2 cubed, which is negative 8, minus 1, negative 9. Well, actually, you know what? It doesn't go up that high. And negative 9 is up here somewhere. So at negative 2, you'll have negative 9 like up here somewhere. At negative 1 cubed is negative 1, minus 1 is negative 2. Let's see, well, negative 2. I'm sorry. Actually, hold on. There we go. I graphed it in the wrong level. Instead of being up here, it should be down here. So we have at negative 2, we have at 1. At 0, you're going to have negative 1 because 0 minus 1. So I'll put at 0, negative 1. At 1, hold on. At 1, 1 cubed is 1 minus 1. I'm going to be at 0. Because if you have 1 cubed, 1 minus 1, I'm going to be at 0. So, and then at 2, I'm going to be at 2, I believe, let's see, 2 cubed is 8, minus 1 is 7. So it's going to follow something that looks like this. And the cubic function usually goes a little bit, well, actually, hold on. The cubic function usually goes something like that. So I'm not far off. I'll say that point goes, there we go, and this goes a little bit like that. Alright, so I'm not that far off. My curve is going to look a little bit like this. So if we do the horizontal line test, you can see if we go through all those times, you'll notice that it does have an inverse function because it only hits the graph once if you do the vertical line test. So if in fact it does, I have to reflect across the line y equals x, since it has. So what I do now is graph the reflect across is I want to graph the line y equals x, and that's easy to graph because since it's y equals x, if x is -1, y is -1. If x is 0, y is 0. If x is 1, y is 1. That's why it's called y equals x. So when you plot that line, that's going to look a little bit like that. Now, what we're doing is we're taking this red line right here, and you want to flip it around that, that dotted line to make what the graph is. Another way to do it, if you want like guidance how to do that, is notice here the line here, well, the point right here is -1, -2. So then the point on the other side of the other line is going to be -2, -1. You can actually reflect that way. You can take this one, the same thing. You have -1 right here. Well, actually, this is 0, -1. It's going to be -1, 0, so on and so forth. So when you plot it, that line should look like that. So that's the inverse function of the blue line. The blue curve is the inverse function of the red curve. So we got that part. Now we can actually find out what the inverse is. We use this notation here. You just say f inverse of x. And we're using the same function, f of x equals x cubed minus 1. So let's go through it. First thing you want to do is replace f of x with y. So instead of f of x equals x cubed minus 1, y equals x cubed minus 1. Next thing you want to do, switch the places of x and y. So just take this and switch them. So now what you're going to end up with is x equals y cubed minus 1. After that, we're going to solve for y. Solving for y, you should go ahead and get y by itself. After you get y by itself, we'll take the cube root of both sides. We got the function. We have y equals the cube root of x plus 1. So then from there, we have the inverse. So we just change this y back into the inverse, and bam, we have it. F inverse of x is equal to cube root of x plus 1. And that's how we find the inverse algebraically. Now, we can do it to this one. Try to look back at the example we just did and try to do it on this one. Pause the video and see what you get. So pause the video right now and see if in fact you can do this one. And go. First, I plotted the line f of x equals 2x plus 1. Obviously, if you do the horizontal line test, it only goes through once. So this is a function. So keep from there, you have to draw the line y equals x. So pause the video and try to draw the line y equals x. There's the line y equals x. And we're going to reflect around. We're going to go about that line on the other side. So try to do that and come back. And I finished plotting the lines. Notice that one reflects around the line y equals x. And then algebraically, once I found out it was an inverse function, I defined the inverse. So substituting in y, we'll switch to x and y, then solve for y, flipped it around the equal sign, and then that gives me f inverse of x equals x minus 1 over 2. So that's how we do those. We'll do more in class. I hope this video was helpful. Goodbye.